part 2 of Module 7, Lesson 6, we're going to continue our study of inequalities. We're picking up on the Learn to Write Inequalities, where they talk about how inequalities can be used to represent real-world situations. Once again, we've got those common phrases there to represent greater than, less than, greater than or equal to, and less than or equal to. It would be pretty good for you to familiarize yourself with each of those terms. To write a real-world situation into an equality, the first thing you need to do is describe the mathematics of the problem. You need to be able to say in words, what is going on here? From there, you need to be able to find yourself a variable to represent that unknown quantity, and after that, you have to create an inequality. Now, you'll find that those steps look very familiar to you because that's the same exact process we used when we were studying how to create equations. Now, for our example problem, they say that a certain semi-truck can hold no more than 24 tons of material. No more than, of course, means it could hold less than 25 tons, or it could hold exactly 25 tons. But if you go to that 1 little ounce over 25 tons, then you have exceeded the weight limit of that truck. This can be represented by the inequality x is less than or equal to 25, where x represents the weight of the material that the truck is carrying. For example 3, Dylan is riding go-karts, and it says he can spend at most $18 on go-karts and playing games at the state fair. Suppose the go-kart tickets cost $5.50. Write and solve an inequality to determine the amount Dylan can spend on games if he only rides the go-karts once. Then interpret your solution. So what do we have going on here? We've got to figure out how to say, once again in words, what is actually transpiring here. And in words, what we have is you have the cost of the go-kart ride plus the cost of the games he wants to play has to be less than or equal to the amount of money he brought with him, which I think was $18.50. Moving along here, your variable, they let x equal the cost of games. I would have used g, x is just fine. And then from there, they took and created their inequality that said the $5.50 for the go-kart plus x dollars for the game had to be less than or equal to the $18 that he brought to spend there. From there, we're going to move on to solving that inequality, and you're going to treat it just like you treated an equation. No difference at all. We're going to isolate the variable by subtracting the 5.5 on both sides, and when we do that, we find out that x is less than or equal to $12.50. So, interpreting the solution, he can spend no more than $12.50 on the games. He can spend $5, he can spend $12. He could spend $12.50. He cannot spend $12.51 because he doesn't have that much money. Caleb owns 2 types of dogs. The difference in the height of his Yorkshire Terrier and his Great Dane is at least 25 inches. I'm going to say there'd be a lot more than 25 inches difference between those 2 dogs. Caleb's Yorkshire Terrier has a height of 6 1/4 inches. Write and solve an inequality to determine the possible height of the Great Dane. Interpret your solution. So once again, we need to work on putting it in words, figuring out what we have going on here. In words, we can say that the Great Dane's height minus that 6 1/4 inches height of the Terrier is going to be at least means greater than or equal to 25 inches. Defining our variables, the variable is going to equal to h for the Great Dane. I would have done g or d, but hey, h works, height. And then your inequality is going to be the height of the Great Dane minus the height of the little ankle biter is greater than or equal to 25. That's all there is to laying out this inequality. And from there, we're going to solve it just like we solve any other inequality or any equation involving fractions. Only they did it vertical, and you all know I really don't like doing fractions vertically. So instead, I'm going to bring up some clean slate here, and we're going to paste that in and work it right here. I'm going to work it horizontal by doing this. I'm going to rewrite it as your height minus 6 1/4 plus 6 1/4 is greater than or equal to 25 plus 6 1/4. These are going to zero each other out, leaving my height is greater than or equal to. And now I'm going to do something a little different. Rather than changing all these into improper fractions, I'm going to take and, actually I don't even need to do that. 25 plus 6, because we're adding, 25 plus 6 is going to be 31 and 1/4. Oh, that's the wrong number there. 1/4. That's going to end up being our final answer. So our height is going to be greater than 31 and 1/4. Jump back over here, type it in. 31 and fraction 1/4. Accept and check. And it checks. It's that easy. So we know that the solution of the inequality is that the height of the Great Dane is greater than 31 and 1/4 inches. The next thing we get to do is graph that inequality on our number line. So we're looking for a value that's greater than or equal to 31 and 1/4. So we're going to take and grab the solid circle, since it is an or equal to. I'm going to start at 31 1/4. It's greater than or equal to. That means our graph is going to go to the right, and the answer checks. Nothing to solve in these problems. And now it's time for your final practice problem in this lesson, extra example number 4. Go ahead and pause the video and work on it. The difference between the high and the low temperature Monday was more than 37 degrees Fahrenheit. The low temperature on Monday was -5 degrees Fahrenheit. Write and solve an inequality to determine the possible high temperature for Monday, and then interpret the solution. Well, we know that we're starting at, or we have to end up with a final answer that is greater than 37 degrees Fahrenheit. So you can see that one has a number greater than 37. That one has a number greater than 37. So right now I've narrowed it down to A and B more than likely. And then I'm going to take and say that the low temperature, the difference between the low temperature Monday was 37 degrees. The low temperature on Monday was -5 degrees Fahrenheit. So if we were to take and remember, this is tricky because we're dealing with negatives here and subtraction. It wants us to find the difference, and the difference, as you recall, is the answer to a subtraction problem. So right here, I can take and say the temperature, the high temperature, minus your low temperature, and the low temperature was going to be -37. That in of itself is going to be our equation. It looks pretty tricky because you're minusing a negative there, but it actually works. Next, we get to solve that problem. T minus a -5 is greater than 37. So I'm going to get some clean real estate here. Write my problem. T minus a -5 is greater than 37. From here, I'm going to make the ugly problem pretty by multiplying the signs. T plus 5 is greater than 37. And then I'm going to isolate my variable by subtracting 5 on both sides. -5, -5. Those zero out, leaving T is a value greater than 32 degrees. So the high temperature on that day, it was still very cold. It was going to be a temperature greater than 32 degrees, which means it could be 33 degrees, something like that. But our inequality is going to be T is greater than 32. Check that. Interpret the solution. Monday's high temperature was exactly 32. Nope. More than 32. Yes. Less than 32. No. That's solution to that. Go ahead and get started on your homework. Be sure you give me the same kind of quality supporting work I've been showing you so I can give you good credit for doing it.